Welcome to another deep dive, and today we're tackling artificial intelligence, AI for short.
A fascinating topic.
We're going to be looking at AI from two different perspectives.
Okay.
Melanie Mitchell's book, Artificial Intelligence, A Guide for Thinking Humans, and Stanislas Dehaene's How We Learn, Why Brains Learn Better Than Any Machine for Now.
Two very different perspectives.
So we're going to be looking at, trying to go beyond all the hype and trying to get a clear-eyed view of what AI can actually do, what it can't do,
Yeah.
and what it all means for us humans.
I think the first thing to do is to kind of clarify what we even mean by the term AI, artificial intelligence, because it's often used as kind of a synonym for deep learning these days.
Right.
And deep learning is a very specific and actually quite limited approach to AI. So it's kind of like, if AI is a vast culinary world,
Okay.
deep learning is one technique, like baking bread. Baking bread is great,
Yeah.
but it's not the whole of the culinary world.
Right.
So there's a lot more to AI than just deep learning.
Okay, so that's a good distinction to make right at the start.
Yeah.
And I think, it also sort of helps to understand the history of AI, this whole debate between symbolic AI and subsymbolic AI.
Yeah, that's a long-standing debate in the field, and it's kind of a, one way to think about it is
Yeah.
symbolic AI is like giving the computer a dictionary to understand a recipe.
Okay.
You're giving it human interpretable symbols and rules.
Okay.
So early chess programs, for example, worked in that way. A lot of expert systems where, you basically program in logic and pre-programmed steps.
Okay.
Subsymbolic AI is more like letting the computer experiment in the kitchen until it figures out how to bake the cake.
Okay.
So it's learning patterns from data,
Right.
much like our brains do. At least that's the idea.
So deep learning would fall under subsymbolic AI.
That's right. Yeah, deep learning is part of that subsymbolic approach.
Okay, and so there's also a fascinating history behind this whole evolution of deep learning and neural networks.
Right.
There was this initial excitement about perceptrons.
Yeah, so back in the 50s and 60s, people
Yeah.
got really excited about these things called perceptrons, which are very simple neural networks.
Right.
They could do things like recognize handwritten digits.
Oh.
Remember those old bank deposit slips?
Yes.
Yeah, people were trying to get computers to read those.
Right.
So there was this initial excitement,
Okay.
but then perceptrons were found to have limitations.
Hmm.
And at the same time, symbolic AI was making all sorts of big promises. And so there was this period called the AI winter where progress kind of stalled,
Right.
funding dried up,
Hmm.
people got disillusioned.
Yeah, and then neural networks made a comeback,
They did!
like a phoenix from the ashes.
Right. So researchers like David Rumelhart and James McClellan wrote this very influential book called Parallel Distributed Processing, and they really championed these networks, which now were called connectionist networks. And they argued that these networks, which are inspired by the brain,
Right.
were much better equipped for tasks like perception and language understanding and memory retrieval, all the things that symbolic AI was struggling with.
So this is what's led to the whole deep learning revolution that we see today.
Yeah.
And behind that revolution are convolutional neural networks, ConNets for short.
Gone sets.
And these are the things that are responsible for a lot of the breakthroughs in computer vision.
Right. From image recognition to self-driving cars.
Right.
Conv nets are really behind a lot of it.
But how do they actually work?
So you can think of a conv net like a detective meticulously analyzing a crime scene.
Yep.
They start by looking for simple clues like edges and textures,
Okay.
and then layer by layer,
Hmm.
they piece these clues together to form a more complete picture
Right.
and eventually recognize complex objects like faces or cars or whatever it is they're looking for.
So it's somewhat analogous to how our visual cortex works.
Right, so there's some inspiration from the brain in there.
Okay. And the ImageNet dataset played a significant role in the rise of convets.
It did. So ImageNet is this massive collection of labeled images,
Yeah.
and it really provided the fuel for deep learning to take off.
So it was like this vast training ground
That's right.
for the convets.
Exactly. They could learn and refine their skills.
And there was the ImageNet competition,
Yeah.
which really showcased how well these convets could do.
So the ImageNet competition started in 2010.
Okay.
And in the early years, there were all sorts of different approaches being tried.
Right.
But within a few years, the convents, powered by deep learning, were just leaving the competition in the dust. Their accuracy just skyrocketed, and this led to what people called the convet gold rush in industry.
So we often hear claims that machines are now better than humans humans at image recognition.
Right.
Because they have these lower error rates on ImageNet. But is that really a fair comparison?
Not necessarily. So one thing to keep in mind is that correct on ImageNet often means the right category is among the top 5 guesses.
Ah.
It's not necessarily the top guess.
So you could get multiple choice questions, right, by just narrowing it down to a few possibilities.
Exactly.
Doesn't mean you really know the answer.
Right.
And comparing human and machine error rates is also tricky because we don't really know how humans would do on ImageNet. And using top 5 accuracy as a comparison metric is also maybe not the most meaningful thing to do.
Right. And I think the deeper point here is that these connets are learning statistical associations in the data.
Okay.
And this is not necessarily the same as human understanding. They might be picking up on subtle correlations that we don't even notice.
Okay.
And this can lead to some unexpected errors.
Right. So, for example, like a network that learned to identify animals,
Right.
but only if the background of the image was blurry.
Yeah, that's exactly the kind of thing that can happen. And it shows you that it's not really understanding what an animal is.
It's just recognizing some sort of statistical pattern in the pixels,
Right.
which we would never even notice as humans.
Exactly.
And this leads to this whole, intriguing concept of adversarial examples.
Yeah.
These are images that are designed to fool convnets,
Right.
but they look perfectly normal to us humans.
And some of the examples Mitchell gives in her book are pretty amazing.
Yeah.
Images that look like random noise to us are confidently classified as specific objects by convnets.
Wow.
And you can even make very simple manipulations like putting stickers on a stop sign.
Yeah.
And that can cause a convnet to misclassify it.
Right. So these adversarial examples raise some pretty serious questions about what convnets are really learning
Right.
and how robust they are in real-world scenarios.
Exactly. Are they really grasping the essence of an object? Or are they just picking up on these superficial patterns that can be easily exploited?
Right. And convnets don't have any of the background knowledge and common sense that humans have.
Right. They don't understand 3D shapes. They don't understand object functions. They don't understand the context in which objects usually appear.
They're just looking at patterns in the pixels.
That's right.
And this makes me think about the whole question of human learning versus what we see in AI.
Yeah.
Are there shared principles?
Right.
Or are we dealing with fundamentally different mechanisms?
So this is where Dehaene's work comes in. He really gives us a lot of insight into the human brain.
Right.
And what's interesting is that both machine learning and human learning do involve building internal models of the world. Both systems adjust those models based on feedback.
Okay.
And error correction is crucial in both cases.
So in a sense, both AI and humans are trying to decipher how the world works.
That's right.
But through very different approaches.
Yeah.
And what are some of the key differences in those approaches?
Well, AI excels at processing vast amounts of data and identifying complex patterns, but it often requires massive data sets and explicit supervision.
Right. And humans are remarkably data efficient.
We are.
We can grasp new concepts from just a few examples, thanks to our innate knowledge and our ability to abstract.
And our knack for social learning.
Right. It's like we have this built-in starter kit
Yeah.
that AI systems are still trying to piece together.
Dehaene gives this great example of the Tsimane children in the Bolivian Amazon.
Right.
Who acquire fluency in their language despite very limited exposure.
Right. And you compare that to the massive data sets needed for these AI language models.
Yeah.
It really makes you appreciate how efficient the human brain is.
It does.
So what makes us such efficient learners?
So Dehaene outlines these 4 pillars of human learning that all work together to make us such adept learners.
So this is like a recipe for successful learning.
Yeah, you could think of it that way.
Okay, so let's delve into each one and see how they work.
Okay, so the first pillar is attention. And this is all about filtering out distractions and zeroing in on what matters.
Right, so it's like a mental spotlight.
Yeah, that you can direct at the most important information.
So if you're trying to learn something new, you got to tune out the noise.
Right.
And focus on those key details.
The next pillar is active engagement.
Okay.
And this is about learning by doing, experimenting.
Right. So it's not enough to passively absorb information.
Yeah.
You've got to actively interact with the world.
The third pillar is error feedback.
Okay.
And this is about embracing mistakes as opportunities for growth.
Right. So it's seeing those mistakes not as failures, but as valuable feedback.
Exactly.
And then the final pillar is consolidation.
Right.
And this is where we strengthen memories through sleep and spaced repetition.
So it's like hitting the save button on your brain,
Yeah.
integrating that new information.
Right, into your existing knowledge base.
And Dehaene really stresses the importance of sleep in this consolidation process.
Yeah, he does.
He even mentions that what we learn in the morning fades more quickly than what we learn before sleep.
Mm-hmm.
It's as though our brains are doing some overnight processing,
Yeah.
organizing those new connections.
Right.
But Dehaene takes it a step further,
Yeah.
suggesting that sleep not only prevents forgetting, but it actually facilitates additional learning.
Mm.
He cites studies where people's performance on tasks improved after a night of sleep,
Wow.
even without further practice.
It's like our brains are figuring things out while we're snoozing.
That's right.
So a good night's sleep is essential for learning.
It seems to be.
And then,
And then Dehaene connects these 4 pillars
right.
to the importance of curiosity in play.
Right.
He argues that curiosity fuels active engagement and exploration,
Okay.
and play provides a safe space for experimentation and error correction.
So those childhood games and experiments weren't just for fun.
No.
Or laying the groundwork
Yeah.
for our learning abilities.
Exactly.
But here's the thing. AI systems currently lack that intrinsic motivation
Right.
and flexibility.
They don't have that innate drive to explore and discover on their own.
Right.
So while AI might be able to beat us at chess or Go,
Right.
it still struggles with that kind of playful, open-ended learning that comes so naturally to us humans.
Mm.
And this raises some big questions about the future of AI.
Yeah.
Will AI ever attain true human-level intelligence?
Right.
Are we on the cusp of the singularity, or is that just hype?
Right.
And what does this all mean for us humans?
Right. These are questions that a lot of people are thinking about.
Yeah.
And for good reason.
Yeah.
AI is a powerful tool.
It is.
It has incredible potential benefits,
Right.
but also potential risks.
Right.
And it's crucial to have a clear-eyed understanding of both.
Yeah.
So Mitchell, in her book, tackles these questions head on.
She does.
She acknowledges the hype surrounding predictions of imminent superintelligence
Right.
and the singularity.
Right. That point where AI surpasses human capabilities and then things become unpredictable.
Right, those sci-fi scenarios.
Yeah.
So you always bring a grounded perspective.
Yeah, I try.
What's a realistic outlook on the future of AI?
So both Mitchell and Dehaene agree that while AI has made remarkable strides, general human-level AI remains a distant goal.
Okay, so no robot overlords anytime soon.
Not that we can see.
But what are some of the hurdles AI still needs to clear?
The challenges of common sense,
Right.
abstraction, and moral reasoning, these remain formidable.
Right, those are the things that we as humans excel at,
We do.
but they've proven incredibly difficult to replicate.
They have.
It's like that saying, the things we take for granted are often the hardest to explain.
Right. We effortlessly navigate the world, make judgments, comprehend complex social situations. But
Right.
translating those abilities into algorithms,
Right.
that's proving to be a monumental task.
And Mitchell also goes into this whole long tail problem, where AI systems struggle with uncommon but potentially crucial situations
Right.
that they haven't encountered during training.
Right. So imagine a self-driving car encountering a flock of birds on the road,
Right, right,
or a language model trying to decipher a sarcastic joke.
right.
These are the scenarios where human flexibility and common sense really shine.
Right.
We draw upon our vast experience.
Yeah.
We adapt to new situations.
Right.
We reason about cause and effect in ways that AI systems are still struggling to grasp.
Right.
And Mitchell gives some compelling examples
Yeah.
of how AI falls short in these areas.
Yeah, I remember that example of the photo of Barack Obama stepping on the scale
Yeah.
while someone else is being weighed.
Right.
And we as humans can look at that photo and instantly understand the humor
Right.
and the implications of that situation.
Yeah, right.
But an AI system is probably just going to get confused.
It's going to be like, wait, what's going on here?
Right, right,
It all comes back to that idea of context and background knowledge.
right.
We bring a lifetime of experiences and implicit understanding to these situations.
Right.
While AI systems are still operating with a much narrower set of inputs and rules.
It's like the difference between understanding a sentence and understanding the whole story.
Exactly.
And Dehaene really emphasizes the importance of abstraction and analogy in human learning.
He does.
You know, our ability to recognize patterns, categorize concepts,
Right.
and apply knowledge from one domain to another.
Right, and he gives this great example using Bongard problems.
Yeah.
These are visual puzzles where you have to figure out the rule that separates two sets of images.
Right.
And it's all about spotting abstract patterns and making subtle distinctions.
Okay.
And these problems really highlight the power of human visual perception
Okay.
and our ability to discern what's relevant and what can be ignored.
Right.
AI systems often stumble on these tasks because they lack that inherent ability to abstract and generalize.
It's like AI is still stuck in the literal phase.
Yeah.
While humans are fluent in the language of abstraction
Right.
and metaphor.
Exact.
And then there's the question of creativity.
Right.
Can AI truly be creative?
Right.
Or is it just mimicking human creativity based on the data it's been fed?
Right.
So Mitchell explores this through the lens of art and music generation.
She does.
She talks about Harold Cohen's program, Aaron, which could generate original artwork.
Yeah.
But even Cohen acknowledged that the creativity ultimately stemmed from his artistic choices
Yeah.
and the program's constraints.
Right.
She also discusses David Cope's system, EMI,
Right.
which could compose music in the style of famous composers.
Yeah. And EMI's output was impressive,
It was.
but it lacked the emotional depth and originality of the composers that it emulated.
Right, so AI can create things that resemble human art,
Yeah.
but it's still missing that spark
Yeah.
of genuine creative inspiration.
Right.
So this brings us back to this question of where is AI headed
Yeah.
and its role in our lives, with its potential benefits and risks.
Right.
It's clear that AI development requires careful consideration and ethical guidance.
It does.
And Mitchell really advocates for regulations that go beyond just the technical aspects of AI.
She does.
And she emphasizes this need for social and political engagement
Right.
to ensure responsible development and use of AI.
Because AI is a tool that reflects the values and intentions of its creators.
Right.
It's up to us to shape its development in a
Right.
way that benefits humanity.
And this is where Dehaene's insights into human learning become so relevant.
They do.
Because by understanding AI's strengths and limitations,
Right.
along with those unique qualities of human intelligence,
Yeah.
we can better navigate
Yeah.
this rapidly evolving landscape.
Yeah.
It's like we need to be both AI literate
Right.
and human literate
Yes.
to make sure we're using this powerful technology wisely.
Absolutely.
And we need to be mindful of those potential biases in AI systems,
Right.
the implications for job displacement, the ethical considerations of granting machines more autonomy.
Yeah, it's a lot to ponder.
It is.
But it's crucial to have these conversations now.
Right,
While AI is still in its relatively early stages of development,
right.
both Mitchell and Dehaene leave us with some really thought-provoking questions.
Yeah.
Mitchell asks, what aspects of human intelligence do you think will be most difficult to replicate in machines? And Dehaene challenges us to apply what we've learned about human learning to our own lives.
Yeah.
He asks, considering those 4 pillars of human learning, what steps can you take to optimize your own learning process?
It's a call to action.
It is.
So the best way to stay ahead of the AI curve is to keep learning,
Right.
keep growing.
Keep pushing the boundaries of our own human potential.
Well said.
Thank you.
This has been quite a deep dive
It has.
into the world of artificial intelligence.
A fascinating topic.
And you've given us a lot to think about,
I hope so.
from the inner workings of neural networks
Right.
to the remarkable abilities of the human brain.
Right.
We've explored this fascinating world of AI
Yeah.
and its implications for humanity.
We've seen how AI is already transforming our lives,
It is.
from how we search for information to how we diagnose diseases.
Right.
And we've glimpsed the incredible potential of this technology
Yeah.
to address some of the world's most pressing challenges.
But we've also acknowledged the potential pitfalls,
We have.
from biased algorithms
Right.
to the erosion of privacy.
It's a reminder that AI is a tool that demands careful consideration
Yeah.
and ethical guidance.
As we move forward,
Yeah.
it's so crucial to engage in thoughtful dialogue,
Right.
to ask those challenging questions,
Yeah.
and to ensure that AI development aligns with our values and aspirations.
It's a challenge that calls for collaboration across disciplines, from computer science and engineering to psychology and philosophy.
Right.
And ultimately, it's a challenge that rests on our shoulders as individuals and as a society.
So what does all this mean for you, our listener?
That's a great question and something we'll pick up on next time.
Great. Well, join us next time when we continue to explore the world of AI.
Looking forward to it.
All right. See you then.
See you then.